Hi guys, so today we'll be discussing your first lesson in chemistry, that is chemical reactions and equation. Okay, so for today's session we have to answer three important questions. First one is, what is a chemical reaction? Basically the definition of chemical reaction. Then the next question is, how do you know whether a chemical reaction has taken place or not? So, evidences for chemical reaction. How do you know whether a chemical reaction has taken place or not? And then in the next half of today's session, we'll be discussing how to write a chemical equation. Okay, so these are the three important topics. So let's get started. What is a chemical reaction? Okay, as you already have learned in class 9th, okay, there are physical changes, then there are chemical changes. So in a physical change, the initial substance does not change, it is not modified, whereas in a chemical change the initial substance is modified, and most importantly you get a new product. That is how we differentiate between a physical change and a chemical change. A chemical reaction is nothing but a chemical reaction. Chemical reaction and chemical change both are one and the same. So what is a chemical reaction? A chemical reaction is one where a new product is formed. So you have a reactant or reactants which at the end are converted into products. The reactant is completely different, the product is completely different. That is a chemical reaction or a chemical change. The next question that we are going to answer is, how will you know whether a reaction has taken place or not, or more specifically, how do you know whether a chemical reaction has taken place or not? So before we go on further, we'll do a very interesting activity, and I want you to observe very keenly, and then we will answer this particular question. Okay, so what we will do is, a beaker, and in the beaker we have distilled water. Okay, so and I'm also going to use an indicator. This will tell us whether a chemical reaction has taken place or not. So this is a what is called as a phenolphthalein indicator. Okay, so this indicator, the specialty is it will show a color change into pink. The color will change into pink when a reaction has taken place. So this is distilled water. To this I am going to add 2 to 3 drops of phenolphthalein indicator. That's it, enough. Okay, so as you can see, I am mixing it properly, and the color is as it is. There is no change in the color. Next, what am I going to do? So I have taken water, that is the reactant. Now to this I am going to add sodium metal. There is a sodium metal here. Sodium metal is always immersed under oil or kerosene because it is highly reactive metal. So I have a small piece of sodium metal which I am going to remove using my spatula. Then I am going to blot it dry using the blotting paper. So using a blotting paper, we have to press it so that we remove all the kerosene present in that, or else that would hinder us in the chemical reaction. So now that is done, you can see it here. It's a very big piece. I'm going to cut it because it is the reaction of sodium metal with water is a highly reactive reaction. So I have to cut it into a very small piece. So using the back end of a spatula, I am going to cut it. Ideally, you have to wear gloves and eye gear for protection. So please do not try this at home. I am going to take a very small piece, very small piece. Okay, that is it. And then the remaining I am going to put it back. You don't need that. Back in oil. Okay, so here it is. We have distilled water to which we have added 2 to 3 drops of phenolphthalein indicator, and we have sodium metal, pure sodium metal Na, and I am going to add. Observe very carefully. You can see the metal is moving here and there, and you can see gas coming out. You can see vapors coming out. Isn't it amazing? And the color changes from colorless to pink color now, and also you can see gas in the form of vapor coming out. And if I take a bigger piece, it would also show sparks. You will actually get to see sparks. So I'm going to set it aside. That is the end. Okay, so now we have already carried out the reaction and you saw what has happened. Now we have to list down the points of what you observed in this particular reaction. Basically, we are talking about the evidences for a chemical reaction. How do you know a chemical reaction has taken place or not? So, first evidence is there is a change in color, isn't it? Change in color. As you saw at the beginning, it was colorless. As the reaction progressed, it turned into pink color. So, if there is a change in color observed during the reaction, it is an indication that a chemical reaction has taken place. We also saw evolution of gas. A gas is produced. So you could very clearly see the vapors were coming out, which means that evolution of a gas is also an indication that a chemical reaction has taken place, right? Then another evidence or proof is change in state. Change in state. State meaning solid state, liquid state, gaseous state. You already know the three forms of matter. So, in the same reaction, we took sodium metal that was solid, isn't it? Sodium metal was solid, and one of the products was a gas. So, the reactant was water. Water is a liquid, isn't it? Water is a liquid. Then to that we added sodium metal. these two are the reactants, which was a solid, right? And one of the products was a gas. So solid, liquid, gas, which means there has been a change in state. So change in state is also an indication, is an evidence for a chemical reaction to have taken place. Then we have, there could be a change in temperature. Change in temperature. For example, this particular reaction produces lot of heat. It is a exothermic reaction. We will discuss about this in the next class. So in this particular reaction, if you touch the outer surface of the beaker, you would find that the beaker would have become hot. That means during the reaction, heat is produced, heat has evolved. So change in temperature. Now heat can be produced, the beaker can become hot, or the beaker can also become cool, both ways. There could be increase in temperature or there could be decrease in temperature. So change in temperature in general is also an indication for a chemical reaction to have taken place. So the four important evidences mentioned in our NCERT textbook. Other than this, also there are two more things to observe for. You can also look at change in pH. In this particular reaction itself we can observe this thing. That is why I have taken this particular chemical reaction to prove, because it tells us about gas, it tells us about state, it also tells us about change in temperature, change in color, it also tells us about change in pH. pH, as you know, solutions can be either acidic, they can be neutral, or they can be basic. Okay, water, as you know, is neutral, pH will be 7. But once a reaction took place, what happened? There was change in color. The change in color indicates to us that now it has become basic or alkaline. Why? Because the phenolphthalein indicator that we have used, it will work only in a basic environment. So change in pH, either from acidic to basic or from basic to acidic or otherwise, could be an indication that chemical reaction has taken place. And the last one, there could be evolution of what is called as a precipitate. Precipitate. For example, formation of precipitate. Precipitate could be of different color again, yellow color, white color, brown color, etc. So when you mix two solutions, one of the product will be insoluble and it will come out, and that's what is called as a precipitate. So you carry out a reaction, and if you observe any one of these six, you are sure that a chemical reaction has taken place. So let's quickly go through this once again. So what is a chemical reaction? A chemical reaction is one where your initial reactant has been converted into a new product. Definitely the product has to be new, which is different from the parent compounds. So that is a important point. The next question that we asked was, how do you know whether a chemical reaction has taken place or not? We know that if there is change in color, if a gas is produced in the reaction, if there is a change in state from solid to liquid or liquid to gas or any otherwise, if there is change in temperature, and if there is an evolution of precipitate, formation of precipitate, all these are indications of a chemical reaction. Change in pH, we cannot see it visually. We cannot see it. We have to use a pH paper and then check it. In this case, we could see because we have used the pH indicator. So that is why I chose this reaction, because it shows us all these 5 things except the last one. So that is our end of first part of today's session. What is a chemical reaction and how do you know whether a chemical reaction has taken place or not? Now moving on to the next part, that is equation. Here we will be focusing on scientific equation, that is your chemical equations. So firstly we will understand what is a chemical equation and why do you need to write a chemical equation, and thirdly the types of chemical equations. These are very simple topics, very easy to understand. Okay, so now let me come back to this reaction that we did a while ago. What did we do? We took water in a beaker. To that we added our sodium metal, and the reaction took place. Now, if I want to express this reaction, there are couple of ways by which I can do this. Right? One is in the form of a sentence. If I want to express the chemical reaction, I can use a sentence. For example, sodium metal was added to water, at the end of which a gas was produced and there was formation of a new product. This would be in the form of a long sentence and it would be very tedious to understand. To make it the job much more simpler, we would use a equation, a chemical equation. In chemical equations also we can use what is called as a word equation. Word equation. Instead of using that long sentence, we can use it in the form of short words, like we have already done here. Water, and to water we have add, so we can use a plus symbol, added. What did we add? We added sodium metal, so sodium metal. And then what did we get? There is no equal to symbol in a chemical equation. In a chemical equation we do not use the equal to symbol, rather we use a arrow mark. We use a arrow mark. An arrow mark tells us that the reaction is progressing in the forward direction. It is moving ahead in the forward direction. What is the forward direction? Forward direction means it is producing a product. A product is formed. So what product is formed? We saw that a gas was produced, right? That gas is nothing but hydrogen gas. Gas is hydrogen, and other than hydrogen another new product was formed, that is sodium hydroxide. See, now we have represented the chemical change or chemical reaction in the form of a equation using words. So now this is a word equation. We can further simplify this equation. We can make it much more easier to understand. How? Instead of these words, we know these are all chemical compounds or elements, right? And we know that every element or compound can be described using a symbol, chemical symbol, as we have already learned in class 9. Each element or compound can be represented using a molecular formula or a chemical symbol, and that is what we are going to do in a chemical equation. So as a word equation, in a chemical equation the words are replaced by chemical symbols. So water formula is H2O. It is a universal formula, everywhere it is the same, right? We use a plus symbol. Sodium scientific name is natrium. represented by Na. We have the arrow mark. Then we have the first product, sodium hydroxide. Sodium hydroxide, OH. And hydrogen. Hydrogen in nature it is present in the molecular form. Hydrogen molecule is shown as H2. Now there it is. This is our chemical equation. What we have shown here is a chemical equation. It is a very simple representation of a chemical change. Now chemical equation. Why? Because we have used mathematical symbols, mathematical operators like plus sign, arrow mark sign, etc. So, if you were to define a chemical equation, a chemical reaction, you know, where reactants give rise to new product, right? Now, you have to define a chemical equation. What is a chemical equation? You are representing a chemical reaction. That is what is a chemical equation. How? Using your scientific or mathematical symbols. So, in simple words, a chemical equation can be defined as, so it is a representation. The definitions given in different books, different sources will be different. I am using the most simplest one. You are representing a chemical reaction, so it is a representation of a chemical reaction. How? Using chemical formulas, and symbols. Isn't it? You have used chemical formulas and then you have used some symbols. For what? For showing a chemical reaction, which is nothing but chemical equation. Okay, so we can represent a chemical change using a word equation more easily by a chemical equation. A chemical equation is a representation of a chemical reaction using formulas and symbols. Very easy, right? That is the easy part. Now we go to the last part of today's session. Now I have written this chemical equation, right? Before we go to that, I would like to bring your attention to one very important thing. Before we proceed further, you should be well versed in remembering the chemical formulas and chemical symbols, which you have already learned in class 9. Remember your chapter atoms and molecules. So there you know how to write a chemical formula. So please refer to that if you have got any doubts regarding how to write chemical formulas. So the knowledge of proper chemical formulas is a must in order for you to write the correct chemical equation. Okay? Right. Now, if you observe this chemical equation that we have written, it is not complete. It is not complete. It is partially right. Why? Why is this equation not complete? Why is this partially right? Because of the law of conservation of mass.